Hey guys, so in this video I'm going to be talking about bounds, more specifically finding the upper and lower bounds of a number. Now finding the upper and lower bounds is actually pretty easy. The hard part comes when you want to use them in calculations. So when a measurement is rounded to a given unit, the actual measurement can be anything up to half a unit, smaller or bigger. The smaller value is referred to as the lower bound, and the bigger value is referred to as the upper bound. So if I told you that this giant duck weighed 25.2 kilograms to the nearest 0.1 kilogram, to find the upper and lower bounds of the actual weight of this duck, what you would have to do is to divide the unit it was rounded to by 2. So 0.1 divided by 2 equals 0.05. To find the upper bound, what you do is add this 0.05 to the weight that's been given to you. So 25.2 plus 0.05, which equals 25.25 kilograms. For the lower bound, you just use the starting value and take away the 0.05, which gives you 25.15 kilograms. So we can write the interval for the mass of this actual duck like so: 25.15 kilograms, then the mass 25.25 kilograms. Now what this is saying here is that the mass of the duck can be within a range of values. The smallest being 25.15 kilograms, it can actually be 25.15 kilograms. And the value can be greater than this, but less than 25.25 kilograms. So the actual value is greater than or equal to the lower bound, but strictly less than the upper bound. Now I want to quickly talk about truncation. Truncation sounds kind of complicated, but it's a very simple concept. All it means is that if I gave you a number like 24.2731 and I told you that this value was truncated to 1 decimal place, that means you just chop off all the values after the first decimal place. So the value will be 24.2. This is the truncated value. As you can guess here, the truncated values are going to have a slightly different range. They can be anything from 24.2 up to and not including 24.3. So you would write that interval like so. This is your truncated interval. Now let's apply this concept to find the maximum and minimum values for a calculation. So if I told you that this rectangle here has dimensions of, so if you look at the length is 2.5 meters to the nearest 0.1 meters, and the width of the rectangle is 1.6 meters to the nearest 0.1 meters. And then I asked you to find the maximum and minimum values for the area of this rectangle. What you would do is you'd find the upper and lower bounds of each of these terms first. So for the 2.5 meters, the upper bound would be 2.55 meters and the lower bound would be 2.45 meters. For the width, the upper bound would be 1.65 meters and the lower bound would be 1.55 meters. So to find the minimum value for the area of this rectangle, what you would do is times the lower bounds of both of these dimensions together, which would give you, so the calculation would be 1.55 meters times by 2.45 meters, which gives you 3.7975 meters squared. For the maximum area, what you would do is times both of the upper bounds together, which gives you 1.65 meters times 2.55 meters, which equals 4.2075 meters squared. This is the minimum value for the area of the rectangle, and this is the maximum value for the area of the rectangle. So what you'd want to do is use the values for the upper and lower bounds for each of the dimensions in question, and use them in such a way as to give you the maximum possible value and the minimum possible value, should the question be asking you that. I'll give you a few example questions you can try. If you found this video helpful, please like the video and subscribe to the channel so that way you can be updated when I upload a new video. Bye guys.